right, here we go. We are on day 5, unit 4. We're going to be adding and subtracting rational expressions. Yesterday, we did multiplying and dividing. All right, let's begin with our warm-up right here. A cylindrical wooden log with a mass of 1,950 kilograms has dimensions with radius of 0.4 meters and a height of 5 meters. What's the density of the wooden log? So let's recall density. The formula for density is D equals mass divided by volume. All right, so what is the density? So we are looking for D here. Okay, I have to have the mass, which they give us. Now here's the thing, we got to have the volume. All right, we've talked about volume in unit 3. Now this is a cylinder. The volume of a cylinder is pi r squared h. Remember, you have to have that memorized. Okay, so that's pi. In this case, all right, the radius, be careful if they give you the diameter. If they gave us the diameter, we would take half of it. All right, but here this is the radius, so 0.4 squared. All right, and then the height of 5 meters. So 5 right there. Okay, so we got to figure out what this is. And you know what I did not do? I did not have Desmos open. So let me get up a Desmos. All right. All right, so here we go, right here. Okay. And let me go back to my screen. All right, so here we go. What we're going to do is, so the mass, all right, was 1,950, and we're going to divide it by pi. So put pi, 0.4, make sure you square that radius, and then the height was 5. All right, so we figure out that our density is all of this right here. So I just plugged all of this in. I didn't even try to figure out what the actual volume was. All right, and it comes out to be 775.88. We'll round it to the nearest hundredth. And we just put the kilograms over, and we did meters cubed or cubic meters. Whoops. So it's like that right there. Okay. Now, number 2, what is an equation of a cubic function whose graph intersects the x-axis at -2, 4, and 5, and goes through the point 250? Now, I could have asked and said zeros or roots at these, and that it would mean the same thing. Now, remember, we have to think the opposite on this. All right, it is x plus 2, x minus 4, and x minus 5 are going to be factors. However, we may have multiplied this by a value of k. And this is where this point right here plays a role. If they were giving you a graph, you would want to look at maybe the y-intercept, as long as it's not 0, or another point on there. Okay, so here we go. We're going to plug in 2 for x and 50 for y. So 50 equals, we're going to leave the k there because we're going to solve for k. All right, so I'm plugging in 2 for x. All right, so what this leaves us with is that's going to be a 4 right there. That's a -2, and this is a -3. So what is 4 times -2 times -3? Well, it's 24. All right, so we get 24k equals, and I'll put 50 over here. Well, how do we solve for k when I'm looking at something like this? Well, I divide by 24. Well, what comes out of both 50 and 24? Well, you could take a 2 out. 2 goes into 50 25 times. 2 goes into 24 12 times. Nothing else goes in there. So the equation is y equals 25 over 12. And we're going to just leave it in factored form like it asks us to. All right, so here can be our equation. And you can always double check it. All right, so if I take my equation, all right, 25 over 12. All right, and then it's x plus 2, x minus, whoops, minus 4, and oops, minus 5. Hold on. There we go. I got it all in there, maybe a different order. Okay, so here we go. Double check this. I'm going to go to the graph settings. I'm going to go up on this. I'm going to say like -70. All right, and 70 on this. Okay. Let's close that. I can almost see everything, so I can transform it right here. Does it hit the x-axis like it says -2, 4, and 5? All right, that's what it asks us right here, and it does. All right, now the other thing is at 250. So let's see if this point, 2 comma 50, is on the graph. And if you look, it is on the graph. They intersect 250. It's right there. So we must have written this correctly. All right. And then yesterday we took a look at a problem that looked like this. We were multiplying and dividing. Now remember what's something you have to do first. You have to factor. Okay. So factors of negative 35 that add to negative 2 are negative 7 and positive 5. All right. Factors, oh, GCF, I can pull out a 2, so x plus 6. Now, what do you remember we did when it's division? You change it to multiplication and flip this. So the x squared minus 49 is going to be in the denominator. That factors is a perfect square, x plus 7, x minus 7. And then here, what are the factors of 12 that add to 8? Well, that's going to be, oh, wait, let's think about it. I was thinking 3 and 4, but that adds to 7. I needed to add to 8. So 2 and 6. So here we go. Now remember, whatever's in the numerator can cancel with the denominator. But if they're on the same, both in the numerator or both in the denominator, they can't cancel. Well, here's an x minus 7, cancels with that. X plus 6 cancels with that. And what I'm left with is x plus 5 and then x plus 2 over 2. Now, how to check it to see if we did this correctly, we can plug all of this in. And I'm going to plug this in because I know I didn't on a lot of the video yesterday. All right, x squared minus 2x minus 35. Oops. Okay, and I'm going to take that and divide 2x plus 12. Now, watch how I do this. This whole thing gets divided by. So I'm going to highlight the whole thing and then do division. Even if you use the division sign, the line's going to come up like this. So be careful. Okay, and it's going to be x squared minus 49. I'll close that parentheses and then divide x squared plus 8x plus 12. Make sure you're careful how you put the division in because that can affect it. All right, so here we go. Now, let me see what my answer was. My answer was x plus 5, x plus 2, and take all of that and divide by, 2. Oh man, what did I do wrong? You know what? I see what I did wrong. I forgot the x plus 7 down here. Okay, so let's put the x plus 7. All right, now is it the same graph? When I take the blue out, I see the red there. There you go. That's how you know if you did it correctly. Now, sometimes they'll multiply this numerator out if it's a multiple choice. Just be careful about that. All right, so we did a little bit of review. We reviewed from yesterday as well. So let's go ahead and get into today's lesson. But let's start out by simplifying this by hand. Let's add these fractions. All right, because today what we're going to do is add and subtract rational expressions. So when I add fractions, what do I need? Well, I need, if you said a common denominator, you would be correct. Now, I like to have something that's a different color. So choose something that's a different color because here, think about it. What's something 3 and 7 go into? Well, it's 21. All right. So my new denominator is going to be 21. Okay. And I'm just going to put everything over 21. Okay. So let's think about this for a second. What do I need to multiply 3 by to get 21? Okay, well, I need to multiply it by 7. Well, whatever you do in the denominator, we do up top. Okay, now I'm not going to put 2 times 7 here. I'm just going to put what 2 times 7 is. It's 14. And this is a plus sign. And I'm going to do the same thing here. 7 times what gives me 21? All right, it's going to be 7 times 3, top and bottom. Well, that's 21, which I already have, but 5 times 3 is 15. And now remember, simplify the numerator. So 14 plus 15 is 39 over 21. Now, in some cases, and actually it happens here, okay, and actually it's not 39, it's 29. Had it been 39, something else would have reduced. Here, actually, since it's 29, it doesn't reduce, but we would be looking for something that might possibly reduce here. 29 over 21 doesn't. Okay, so let's apply this to rational expressions. We're going to state any restrictions. We're going to start to do that, but we may not do that every single time. All right, so look at these denominators right here. Now, one of the things with denominators is you only want to multiply to denominators. You never want to add or subtract. So keep that in the back of your mind. All right, so here I see a B here and I see an A. I got to get these to look alike. Well, they have nothing in common. All right, this one needs an A multiplied and this one needs a B multiplied. Now, do my denominators look alike? They do. It's an A and a B. All right, so here this makes 2A squared. That's a plus. And then 8B squared. All right, now when you're doing this, just double check. Can anything factor out of the numerator? If nothing can factor out of the numerator, here a 2 does factor, but let's look at it. When I factor out a 2, I'm left with this right here. Okay, this is not a perfect square because that is not a minus in the middle. I don't have an A and a B that divides out of everything, so I can't factor it out. The only thing that's going to happen to cancel out of the bottom, it has to factor out of the numerator, and here it doesn't. So we just leave our answer like that. Now, this has 2 variables in it, so I can't graph it to verify that I actually did this right. All right, so let's move on. Now, if I just have a number right here and it doesn't have a denominator, please put a 1 there. Okay, and anything that has a plus or minus, it's a good thing to put parentheses around it like that. Okay, let's get these denominators to look alike. Remember, only multiply to denominators. Okay, so here, that has an x plus 4, that has a 1. If I would multiply this by x plus 4, top and bottom, do you see how the numerator equals x plus 4? I mean, denominator. So my common denominator is x plus 4 right here. All right, now, as far as writing R's, a lot of you will sit here and write this, and I want to use this as an example. It's okay to do this and write that, and then this is minus x minus 1, but some people have a tendency of marking out the x plus 4s here because you think they cancel. They don't. So what I like to do instead is actually in my head, go ahead and distribute this 4. So it's a 4x, and then 4 times 4 is 16. And then here, be careful when you have a minus. This is like having a negative 1 out there. And I would distribute the negative 1, kind of like right here. I would distribute it. So that's negative x. And negative 1 times negative 1 is a positive 1. Now let's simplify that numerator. 4x and negative x makes 3x. 16 plus 1 is 17. Now, does anything factor out of the numerator? No, it would only be the GCF here. And 17 is a prime number, so nothing comes out. So here we go. Now, this is one I can check, and I'm not going to check all of them. All right, my original was 4 minus, okay, x minus 1 divided by, what was it, x plus 4? Okay, and I came up with 3x plus 17. All right, divided by x plus 4. All right, and it is the same graph, so I must have done this correctly. Now, as far as any restrictions on the variable, take a look at my denominator right here, x plus 4. Set it equal to 0. All right, subtract 4, and then x equals negative 4. So basically, actually, x can't be negative 4 here, or it makes the denominator equal to 0. All right, moving on to number 3 right here, common denominator. Again, anytime anything has a plus or a minus, please put parentheses around it like this. All right, so here, I got to get these to look alike. These are totally different. Yes, that has an x. All right, but x plus 5 is totally different from x minus 2. So I need an x plus 5 here, top and bottom. I need an, oh, wait, nope, I don't. I need an x minus 2, sorry. Sorry, that's a minus 2. Here, I need the x plus 5, top and bottom. So my common denominator is x plus 5, x minus 2. All right, so here. Now, please realize I am multiplying out x minus 2 right here and 3x plus 1. Okay, so x times 3x is 3x squared. X times 1 is x. Now, negative 2 times 3x is negative 6x, and negative 2 times 1 is negative 2. All right, now I'm adding, if it's addition, that's easy. I don't have to worry about multiplying through a negative. But here we go. X times X is X squared. X times negative 5 is positive 5 is a positive 5X. Negative 4 times X is negative 4X, and negative 4 times 5 is negative 20. Okay, now add your like terms. Like I have X squared, 3X squared, and 1X squared gives me 4X squared. Now my x's, now there's several of them. 1x minus 6x is negative 5x, and negative 5x plus 5x is 0x, and 0x minus 4x is negative 4x. And then my constants right here, negative 2 and negative 20 make negative 22. All right, and my denominators. All right, now I do notice a 2 comes out of here, so I can factor it. Oops, that's 2x squared left right here. Minus 2x minus 11. All right, x plus 5 and x minus 2. Now, the only other thing I can try to do is, okay, multiply this 2 by that negative 11. All right, and when I do that, I get negative 22. Are there any factors of negative 22 that add to negative 2? There aren't any. So this is my final answer right here. Now, as far as restrictions, think about this right here. X can't be negative 5 and X can't be positive 2, or it makes that denominator equal to 0. All right, let's move right along. Let's look at number 4. And anytime you want to pause, please pause. Now, one of the things you want to make sure of is you want to make sure the denominator is factored. The other ones, the denominator didn't factor, but here it does. A 4 factors out, and we're left with v minus 2. Because if it factors, it could make it look a little bit easier, because if you look, these already have a v minus 2. I just need a 4 here, top and bottom. Remember, multiply. So my common denominator, 4, v minus 2, this is going to make a 20 minus 3v. Nothing factors out of the numerator, so I'm done. Except for, what are some values v can't equal? Well, right here, remember, set that equal to 0, or you may think opposite on it. V is just not going to equal 2 right here. All right, moving right along. Number 5. Now, this one right here, ooh, that's a terrible one right there. Actually, can y'all do me a favor right here? Can you change this so it's a negative 1? All right, I want to make this so it's different. Now, if your paper was already changed, that's fine. Okay, right here. Do you notice anything about those? Do you remember, like, if I switch, I'm going to keep this as 2w minus 1, but I'm going to change this so this is 2w minus 1. And to do that, I would take out a negative 1. Now, and I'm going to put parentheses here. A negative 1 is actually really special because it can float top and bottom. And so what can happen is this negative, I can take it up top and it actually cancels with that minus sign right there. It changes to a plus, which makes it so much easier. And guess what? My denominators are the same, 2w minus 1. All right, so this is 2w plus 5w plus 2. And here I'm left with 7w plus 2 over 2w minus 1. All right, nothing factors out of the numerator, so I'm good. Now, when I set 2w minus 1 equal to 0, add the 1. I get 2w equals 1 and divide by 2. W just can't equal 1/2 right here. Okay. All right. So let's look at number 6 right here. All right, same thing. Do you see how these look backwards? So let's take out a negative 1. And if I take out a negative 1, it makes x minus 8. But that negative 1 can float up top and make a positive right here. Okay, so here, x minus 8. All right, this right here, x squared. Okay, now it's a minus. Okay, or no, it's a plus now, I'm sorry. So actually, what I can do is combine these together. 1x squared and 3x squared makes 4x squared, and then plus 5. Does anything factor out of the numerator? No. And I can tell real quickly, x isn't going to be positive 8 here. All right, number 7 right here. Now, again, I see I need to factor my denominator. So 2 comes out, so that's x plus 2. All right, here, I'm going to put parentheses around that. This is x plus 2, x minus 2. All right, so how am I going to get these to look alike? Well, one of the things I notice is I see this one has a 2 right here. So what if I put a 2 right here? Remember, you're multiplying. And this one doesn't have an x minus 2. I'm going to put parentheses around the x minus 3. All right, now are my denominators the same? Yes, they are. So it's going to be 2x minus 2 and x plus 2. Now here, I'm going to have to distribute. X times x is x squared. X times negative 2 is negative 2x. Negative 3 times x is negative 3x. And negative 3 times negative 2 is a positive 6. Now here, I just need to multiply by 2. 2 times 2x is 4x. 2 times negative 5 is negative 10. Sorry. Add your like terms. So that's my only x squared. Negative 2x and negative 3x makes negative 5x. And negative 5x plus 4x makes a negative x. And then here, 6 and negative 10 make negative 4. All right, now ask yourself, are there any factors in negative 4 that add to negative 1? There aren't any. So this is just going to leave like this. It's just quickly from here, I can see x isn't going to equal 2 and x isn't going to equal negative 2. All right. Now, 8 and 9 look a little different. Your teachers may or may not do this because these are more challenging problems. I apologize. Okay. So here we go right here. If you notice, this is in here because there is a minus sign right here. I know it looks like it kind of goes together. All right. Now what I'm going to do is I'm going to do the numerator and then I'm going to do the denominator. If it's the denominator, if I need to do it. Do you see right here? These almost have the same denominator, except for this one needs a 3. All right. So this is really 3 and there's 3x's down here minus 2. So that makes basically 1 over 3x. Now, do you see how it's divided by 5 over x? Well, what do we do here? 1 over 3x times, we would flip this. This is going to make x over 15x. And what do you notice? The x's cancel. So therefore, now realize 15's in the denominator, so I'm going to have a placeholder of 1. Our answer is going to look like that, 1 over 15. Okay, and it went from this crazy thing like this all the way down to 1 over 15. Okay, now let's talk about this one right here. Now, this is 3 over 1. I'm going to do the numerator, get a common denominator. So this is 7x over 2 plus 3 over 1. Well, here, if I multiply this by 2, top and bottom. Oops, y'all can't see that. Let me clear this up a little bit. There we go. All right, so this equals, my common denominator is 2. All right, this is 7x plus 6. Now, I'm going to deal with this. This is 4x over 3 minus 1 over 5x. Well, guess what? This needs a 5x. All right, this one needs a 3 because there's nothing in common there. Well, my common denominator is a 15x. All right, here that makes 20x squared. All right, minus 3. Now, when I divide, okay, I would multiply and I would flip this over. Now, I'm looking at it and I think, does anything factor? It doesn't. Okay, so really here, I can just multiply across. Nothing even, this 2 and 15 doesn't even simplify either. Okay, so here when I multiply 15x times 7x, 15. All right, my brain's not working, so I'm going to go here and I'm going to say 15 times 7. All right, times 7. All right, that makes 105. There we go. Okay, so 105x plus 6 times 15, that's going to be 90x right here. Oh, I'm in an x squared because x times x is x squared. And then this is just 2 times 20, which is 40x squared minus 6, because 2 times -3 is that right there. Now, again, any of these that just have one variable, we could go graph it. So let me go graph this thing right here. All right, if I put my original in, okay, so that's 7x divided by 2, and then plus 3. Now, this entire thing, so I'm going to highlight it, is divided by 4x over 3, and then minus 1 over 5x. Okay, now my final answer I got is this thing right down here. So 105x squared, all right, plus 90x. All right, highlight it and divide by, so 40x squared minus 6. Is it the same graph? Take it off. I see the red one underneath. So it is. So even if I would have got like a 2 right here instead, do you see, I can see, even though these are very almost similar, I still see the red one underneath there. It's not sitting right on top of it as if I just had 6. So all of these, with the exception of number 1, I could check because this one had 2 variables right here. But the rest of them, you could check with your calculator, with Desmos. Plug in the original, just make sure it's in there correctly, plug in what you got and see if they match. All right. Any restrictions come from the denominator. Just make sure, set each part of the denominator equal to 0. And that's what x can't be because it makes the denominator equal to 0. Again, this is a really tough concept because you got to know how to factor. We also have to know how to get common denominators. So make sure you continue practicing it. Ask your teacher questions. If you need to go watch other videos on YouTube or on the internet, please feel free to do so.